Now we know what a solution to a system actually is, and we know how to plug in different points to see if they actually work. So if I hand you a point, you can tell me by this point, hopefully, if it's a solution to the system or not, just by seeing if it works when you plug it in. As you can probably imagine though, that's not a very good strategy in terms of solving a system. If I just give you a random problem and you just start throwing numbers at it, like, I don't know, I'll try 2 comma 7. No, I'll try like 2 comma 51. No, I'll try like, it's just not going to work out when you plug in point after point. There's no guarantee you're going to get the answer. So we need methods that will actually give us the answer instead of just being basically a guess and check strategy. So there's going to be a bunch of different ways to do this. That's actually the focus of this chapter. We're going to learn 4 different methods for solving problems like the one you see on this slide right here. Our first method is one that kids tend to do pretty well with because it kind of intuitively, hopefully after you see a few, will make sense. But that's solving systems by graphing. The basic idea is that you're going to graph each equation separately, then just see where they cross. That'll be your answer. So my problem here, I have 2 equations, both lines. I'm just going to graph them, and then I'm going to see where they cross. So y equals 1/3 x plus 4. Remember, y equals mx plus b. I start out at my y-intercept, which is 4. And from there, I need to go up 1 over 3, because that's my slope. And when I do that, I'm going to use a ruler right here. It's actually kind of important on these problems that you use a ruler and that you make sure your tick marks are equally spaced, preferably even use graph paper, because your answer will be off. You'll get a wrong answer or an answer that's slightly off if you don't, if you're not careful with your tick marks and stuff. So that's my first graph. Now, every single point on this brown graph is a solution to this equation. We learned that's what it meant to be on the graph. So this random point right here, if I plug in that x comma y to my equation, it's going to work. All the points that work in the top equation are right there. That'll be my brown equation here. I guess that kind of looks black. This is my first equation. I got my brown equation. I'm going to go ahead now and graph my second equation. So I have y equals 2x minus 1. I'm going to start down here at -1, my y-intercept, and my slope is 2 over 1. So I'm going to go up 2 over 1, and when I do that, I land right there. So I'm going to take my ruler right now, and I'm going to go ahead and draw my graph in. And I'm going to take this away now, and all the points on the purple graph are on that line. So the points on this line are solutions in the purple equation. The second one. The points on this line are the solutions in the first. The spot that works in both equations, the answer we're looking for, is the place where they cross, the intersection point, which is right here. That's the answer to my problem. And the coordinates of that point are 3 comma 1, 2, 3, 4, 5. You write your answer to the system as an ordered pair. So it'd be 3 comma 5 for my solution. So if you can verify by plugging 3 in for x and 5 in for y, that is the point that's going to work. One more example on this video. So the problems can get tougher looking, but they work the same way. This strategy for solving systems, graph them, see where they cross. This problem should look a little bit familiar because it's the one we did in our last video. So we already kind of know the answer. I think it was -2 comma 6, if I'm remembering correctly. But we're going to see now how that actually works and how we could find it for real. I don't have y by itself in this equation. I need to fix that if I want to graph it. So that's something we've practiced plenty, just getting y by itself here. So I get 4y equals -2x plus 20. Divide everything by 4. I end up with y equals -2 over 4 is -1/2 x plus 5. So I'm going to go ahead and graph that. 1, 2, 3, 4, 5 is right there. I'm going to go down 1 over 2 because that's my slope. And let me get my ruler out again. That'll be my first equation right here. So, got my first guy graphed. I'm just going to graph the second one now, and then we'll see where they cross. So my second equation is 1/2 x plus 7. That one's already in y equals mx plus b. 1, 2, 3, 4, 5, 6, 7 is up here. And I'm going to go up 1 over 2. I'm on my writing there, but that's okay. And I'm going to go ahead and draw this line in. Let's see. So I draw in my other line. And my solution is that dot right there where the two lines cross. That's going to be the point -2, comma 6, as we saw in our previous video. So on these problems here, the answer was on a lattice point, right on the little crosshair there, where it's a nice whole number answer. That won't always be the case, which is one reason why graphing isn't, like if you're going to do the problem, if I just get a random system problem, I'm probably going to use a different method to solve it that we'll learn in a later video. Graphing is great because it should kind of make sense why it works, and when it's nice whole number answers, it's perfect. But say the answer to the problem was like, maybe the two lines cross like right here. That's not a point you could easily tell me just by looking at it. So graphing has its uses. It also has times when it falls short. But typically, if you're asked to graph a problem, and I'm grading you on if you get the answer right, you should expect it to probably be a nice whole number or integer answer.